You can start. We can see you.
Okay, so welcome everybody. As I said, in this talk, I'm gonna share the experience of sharing code between three different platforms and that are Android, iOS, and the backend. So I'll gonna okay, that's working. So really quick introduce myself. I'm Marco. I'm based in Berlin, and I work for Tier, and I'm a Google Developer Expert for Kotlin. And these are my internet handles if you want to follow me on the web. So let's start with the story. And yeah, in this story, there is Alice that is a mobile developer, and she's working on a feature, and she's working on a news application. And in this application, she needs to show the news basically. So she has to retrieve the data from the backend and use this kind of DTOs. A really simple one. But actually she see that something is not working as expected, and in particular the author strings seems not working because it seems nullable, but it shouldn't. So it double checks with the backend developer, that is Bob. She's asking if the string is actually nullable, and Bob says that should not, because the doc says that, but things are not working. So Bob is checking again, and finally it discovered that there was actually an error. Yeah, and another story just to start with. There is again, this time there is Charlie, that is the product manager, and there is again Alice, that is our mobile developer. And Charlie asked Alice to implement a new logic on iOS. And for Alice, it's not a problem because she's a mobile developer. She knows both the platform. But she quickly realized that she's just converting plain Kotlin code into Swift. So it's kind of boring. And yeah, I started with this true story to introduce the concept, and I can tell you that you are probably experienced with the first story. Everyone had problems. I can be sure of that everyone had problem with DTOs, with nullable feeds and stuff like that. The second story instead, maybe it's more startup specific, because usually there are bigger teams and split between platform. But both of these kind of situation have something in common, that is execution speed. In fact, for this specific reason, our execution speed could be dragged down, because if we have to fix some bugs, if we unexpected bug, of course, then if we have to duplicate work, the time to market is gonna be lower than expected, and a bit more difficult, let's say. So how we can fix that? Well, for example, we can use a classic cross-platform solution like React Native or Flutter, but yeah, these are not so good solutions for some topic. There are different problems that can be with that, because simply trying to unify the UI declaration between different platforms is complicated and is difficult, because different platform and different platform have different patterns, different architecture, different structure. They are different things, basically. So trying to find something that connects and unify these two different things comes with a compromise, and it's not an easy solution. So there could be some problems. For example, in my past company, we had problem with React Native because, yeah, it was too much slow on certain device. So the solution to fix this kind of problem is Kotlin Multiplatform. And that's because Kotlin Multiplatform is not about compiling the entire code for all the platforms, but only a small part of the code, and in particular, only the code that is not UI. So with Kotlin Multiplatform, we can share the entire business logic, everything that we want, but what we cannot share is code that is UI related, or it's platform, or it's really platform specific. And with this kind of thing, we can kind of delete the problems that classic cross-platform solution brings. So, how to approach Kotlin Multiplatform? So, first of all, you are probably starting with an existing project, because it's most likely that you are working on something that already exists. It's starting from a scratch project. It's a rare case, but could happen. But let's say that 90% of the cases you are from an existing project, and so you probably don't have time to do a bigger rewrite, so probably you don't have time to move to a monorepo solution, so you can't have a single project with the Android application, the iOS application, and the shared code all together in the same repo. That's because probably there are constraints on time, or even business constraints. Probably you can't share some repository with other people or stuff like that. There could be many situations. But fortunately, in software development, we can simply ship our code like a library. So in this case, we can make a library of our code, and specifically of our Kotlin Multiplatform code. So we can start, we can choose something that we want to share, and we can create a library out of it, and start shipping that library and use it. Where to start? Well, there are multiple different places where to start. We can start from boring code, some boring code that is boring to write multiple times. And since it's boring to write, there are gonna be errors, because if we get bored, then it's more likely that some mistake can sneak in. Or we can start from code that centralize the source of truth. So, for example, in our story of before, if a field is nullable or not. That's because if we have a single source of truth, then we are going to have also a single point of failure. So there will be only one point of failure, basically, and only one point to where to go to fix that problem. But the most important thing is that we have to start from features that can be gradually extracted, because we are in the process of validating if the entire solution work for us. So we cannot start sharing, for example, the entire network layer, because if this thing doesn't work for us and Kotlin Multiplatform is not the right solution, then we have wasted an infinite amount of time doing basically nothing. So you can start from little. And in reality, what are those places? Well, you can start from DTOs, for example, or you can start from common models that you are using in your business logic, or you can start from utility methods, or that every project have, or you can start from analytics, or from whatever other place that is in your project, and that's specific on your project. You have to choose something that is gonna fix basically your problems, and that is gonna make your life easier. So that's why it's more project specific. Yeah, and for example, in my past company, we started from DTOs because guess what, guess what, now you can understand where the first stories go. So yeah, now that we have a common ground, we can start building. And what we are going to build is something that lives in different repositories. So there will be a repository for the Kotlin code. So and the share code, and this share code is going to generate some binary artifacts. So for the JVM, there will be a jar. For Android, there will be an AAR, that is the equivalent of the jar. And for iOS, there will be a framework that is the equivalent of the jar and AAR for the Apple world. These artifacts will be deployed into the web, into a dependency manager, and then the dependency will be pulled from the different project inside of it, like normal libraries. So for the JVM world, so for Android and the backend, we have used, and you can use Maven because it's mostly the standard one. And for iOS, instead, there are different kind of thing that you can use. We went with CocoaPod dependency manager because we were already using it. Yeah, so what we are going to build is basically an Android and iOS application that show news. And those news comes from Ktor backend. And the two clients and the Ktor backend are sharing the DTOs. So the DTOs are defined into a Kotlin Multiplatform library, and they are basically the contract between the different clients. This sample project is on my GitHub if you wanna to have a look, but it's basically based on the project that we have done in my past company. So it's a sample in miniature, let's say. All right, so let's start. And first of all, we have to create a new project, of course, because we want to create a new library. And in order to do that, I suggest you to use IntelliJ for a library, because the wizard let you create a library and not a mobile project. If you're using the Android Studio, there is a plugin to do that, but the plugin only creates a monorepo structure, and we don't want it. We want to create a library. After that, we need to add the JVM target, because we have choose only the mobile library, and then we had manually the JVM target. And so what we end up to have is a structure like this with three different targets: Android, iOS, and JVM, and a common module where we write all the common code. All right, now let's tackle first the JVM world, because it's easier, of course. And as I said before, we are going to use a Maven repository to share the artifacts. So in order to do that, it's pretty easy, because we can use a Gradle plugin that is the Maven publish plugin. And that's all the code that we have to write to set it up the things. So declare the plugin, define the group of our library, the version, and the repository where we want to publish our thing. And after that, it's time to write some code, of course, finally. And so we can write, first of all, a simple DTO that we need. Yeah, that's it basically, because we have decided only to share the DTOs. And after that, we can start publishing our library. So we can do it with a publish Gradle plugin that gonna appear after defining the Maven publish thing. Or we can also publish to our Maven local repository. If we are testing something local, it's easier and quicker if you want to test it your local machine. Yeah, after that, the library is published and we have to add it into the backend and into the clients. So on Android, we have to implement our dependency that is something like that with the dash Android at the end. We have to implement and define it into the build.gradle file like every other library. Then we can define our network interface with the retrofit in this case, so we can return inside it the DTOs that we have defined previously on Kotlin Multiplatform side. And yeah, that's it for Android. For the backend, instead, we have to do something similar, except for this case, there is dash JVM instead of dash Android. And as I said before, for the backend, I'm using Ktor, that is a Kotlin framework for building both server and clients. And in this specific case, we are going to exposing a single endpoint that answers with a list of news. Pretty simple. Pretty simple. All right. So finally, we have a backend and an Android client that are sharing the DTOs together and are working. Now we have the tough part, that is iOS. And yeah, it's tough because usually on existing projects and most of the stuff that you're seeing online basically is shipping the framework in the monorepo structure. So it's gonna build, they are building a framework and put it in your build folder inside your project, and then the Xcode project is pulling that library automatically, let's say. And that kind of framework is built with a Gradle task that is packed for Xcode. And actually, this task is not available anymore because it has been replaced with another one that is Embedded Sign Apple framework for Xcode. That is, yeah, it's never ending. It's very long, but you never have to call it because this kind of thing is automatically called by Xcode when is building the project. Why it has been replaced? This thing happened from Kotlin 1.5.20, and before that, the pack for Xcode was a task that was automatically added to your project, so it was visible. The code that was triggering was visible in your build.gradle file, and yeah, it's not nice to see something that you don't know what it is in your project. So right now, the Kotlin team decided to move it all together inside the Kotlin Multiplatform plugin. So you're not gonna see anymore, but the concepts are basically the exact same. And the problem with the task, I was saying that it automatically decide if the framework has to be built for production or for debug, and it automatically decided the architecture requirements. So if we are building it from an Intel machine, it's going to be x86, or if we are building for a simulator for a real device, it's going to be ARM64. Yeah, for M1 machine is gonna there will not be this difference anymore, but yeah, let's take it with Intel machines. And yeah, so the configuration and the architecture is automatically decided at, let's say, at runtime when we call the script, when Xcode calls the script. So, but we don't know which architecture and which target the iOS team are gonna use. So we can't use this thing. There is another thing that can be used for create a framework, that is the CocoaPods plugin for Kotlin Multiplatform. And basically this plugin makes the exact same thing. It creates a framework inside the build folder of your project, but this time there is not a script that make Xcode going to look into the framework and embed it into the application, but it's going to be exposed as a local CocoaPods repository, so you can add the framework like you do with the libraries, but is not going to pull the library from the web, but from the local machine. Again, we can't use this because the script that this CocoaPod plugin is exposing does the same, so it computes at runtime the target and the configuration. So what we can do now? Well, we have to ship everything basically because we don't know which kind of combination the iOS team is gonna use. In order to do that, we can use XC framework, that are a new kind of framework introduced by Apple recently, that allows you to ship everything basically. In fact, you can wrap it together, a version for simulators and a version for real devices, but also you can mix it together different OS, so you can target everything that Apple have, so iOS, macOS, tvOS, and watchOS. And yeah, this was not possible before with the FAT frameworks. Yeah, now it's much better because if your Kotlin multi-platform thing is targeting multiple OS, you can target it with a single binary. Okay, so yeah, it was introduced in WWDC 2019. So if you are interested to learn more on the internals of how it works, you can give a look at this talk. All right, so there is fortunately support for XC framework on Kotlin multi-platform, but unfortunately only from Kotlin 1.5.30. Before that, you have to do things manually, and specifically you had to build the framework that you want, and then you had to pack it together with the Xcode build CLI. So since I'm lazy, I wrote a script that does it everything for me. So it builds the different framework, pack it together with the CLI. But I'm not going deep into that because hopefully you will use a new version of Kotlin and not the older one. But if you still stick to older version, I wrote and explained the script in a blog post on my website. So if you're curious, you can check it out. So in a new version, what you have to do is, first of all, import the framework, and then you inside the Kotlin block, it is necessary to create an object that represents the framework, and then for every different target, so iOS, macOS, tvOS, whatever OS, you have to add the framework into the XC framework object. And after doing that, some new Gradle task will appear. So there will be one task for building a debug version of the XC framework, one for building a release version, and one for building both at the same time. These tasks are gonna build the XC framework and put it inside your build folders inside your project. So at this point, you have to ship it somehow. So you can either wrap it into a USB stick and give it to your teammates, but yeah, it's not a scalable solution. So as I said before, you can ship it with CocoaPod, or you can even ship it with the Swift Package Manager. It depends on what you want to use. And for CocoaPod, all you have to do is create a CocoaPod repository. That can be a Git repository, for example, where there is the actual framework, and then there is a podspec file that is a Ruby file with the definition of your library. So where to grab it, which version, the author, etc., etc. This app could be private, so if you can build it, and there is a really good tutorial on the CocoaPod website that you can follow to watch all the steps that you have to do to build it. That's what I follow back then. All right, so now that you have published the library, finally we can start using it in our projects. And so we have to define the dependency in the pod file. That is basically the equivalent of the dependency block inside the build.gradle file in the JVM word. And here we are specifying that we want that library that can be found in that specific Git repository in the develop branch. And I use the develop branch for developer release because I need to iterate quickly and fix things quickly. Yeah, I don't want to waste tags, let's say. But for stable release, I'm using a specific tag from the main branch because yeah, I want that that the library is deterministic, and I want that specific version to be out on production. All right, so we have to do a couple of things. We have to build the framework. We have to move it from the build folders inside the Git repository. We have to commit, push it, tag it, update the version, do a lot of things. As you can guess, I'm lazy, so I build another script to that. So I built two different Gradle tasks that are gonna do the work for me. So one for publishing developer versions, and one for release version. The developer version is gonna, first of all, check out into the develop branch of the CocoaPod Git repository. Then it's gonna build the framework. It's gonna move all the stuff from the build folder to the library. Then it's gonna update the version of the library specifically. Inside the podspec file, and it keeps the library from the build.gradle file. So I have, again, one place where I can update the version. Then it's going to do manually the commit with a standard message and the push into the develop branch. The release task is basically very, very similar, except for the fact that it's going to use the main branch instead of the develop one. Then it's going to build again the release version of the framework. It's going to move it, update the version if necessary, commit and push. But this time it's going to tag the version with the version number of the library. So yeah, finally we have something. we have our library that can be used also on iOS. But we have another problem. And this time is about the serialization of our DTOs because, yeah, it's not out of the box on iOS. And on iOS, probably you are going to use Alamo Fire for this kind of thing, for the network request. But for do the deserialization, probably you're using Codable. That is an Apple solution for doing that. And unfortunately, Codable is not available yet on Kotlin native. So what you have to do is some custom thing. You have to, we can use Kotlin serialization, so we can streamline all the serialization thing into the Kotlin multi-platform sites, but we have to write a custom serializer on Alamo Fire, because Alamo Fire, as you may know, it doesn't communicate with Kotlin multi-platform because are different thing. And sorry for that, I didn't mention that Alamo Fire is basically the equivalent of a retrofit for the iOS world. So in this case, I'm gonna go quickly because yeah, it will require much time. But to do that, you have to implement a function from the retrofit internals, and basically inside that you are gonna bring the response as a JSON string, and then you are sending this string to the serialize method of Kotlin next serialization on Kotlin multi-platform side in order to do the work. And in order to do that, there is an abstract class for every DTOs because, yeah, we cannot use general thing because unfortunately Ray5 types are not available on iOS side. And so we can use generics for that. So we need to have something base. And yeah, in this case, as you may have seen this, the custom serialize is handling generic stuff that are that have as parent class the base one. So in this case, we can have a deserialize common method, and then every DTOs is going to implement it and pass the specific and implement the specific method. Yes, I understand that that is more complicated of that, and I went super quick on that, but we don't have time to dig deeper into that. But again, I wrote something on my blog that explain it, and there is also a sample, and also the sample that I showed before is implemented that. So if you are curious, you can give a look about it. And yeah, finally, there is something that is actually working. And yeah, finally, we have shared stuff between different platforms. So yeah, sorry. Another thing that I forgot to mention is that we have to froze the object. What it means, well, in Kotlin multi-platform, if we want to use an object from another thread, we have to make it immutable. And in order to make it immutable, we have to froze it and call this make frozen extension function on it. And that's because the memory model on Kotlin native is different, but it will change. And there is a new memory model that doesn't require this thing, and is going to be, right now is in developer preview and is going to be stable in spring 2022 with the beta release of Kotlin multi-platform. All right, so now we can finally jump to conclusions. And so, in order to add the Kotlin multi-platform and share and have the sharing scenario, we have faced some difficulties. The first one was how to organize the project properly without a monorepo structure. And that was kind of difficult at the beginning because all the sample all the sample in the web are with a monorepo structure because it's most common and most simple to show. So at the beginning, understand that I have to ship a framework, ship a library, how I can make work all together was not simple. Then another difficult thing was setting up the different task of Gradle, build custom one, and handle the Gradle stuff. But fortunately, I was using the KTS version, so instead of writing Groovy, I had to write Kotlin. That is way much nicer. Then another issue connected to the first one was how to distribute effectively the iOS framework, because it was not so easy at the beginning to understand what I had to do to ship every different piece of architecture. So it was not easy at the beginning. And the last difficult part was to how to handle properly the serialization of the object on iOS. That again was not simple to understand and achieve. But yeah. So from this experience, I extracted a kind of framework that I like to share. That is that if you are starting doing stuff for Kotlin Multiplatform, you have to start little, because you have to understand if it's the right solution for you. You have to write some let's call it DevOps code to orchestrate everything. And when you understood that, you can go bigger and start sharing more and more stuff. That's basically what we had do in my past company. So we started to validate the process with little effort. So we started by sharing the DTOs, and after that we validated the process. We like it; it was really good. So we decided also to share the entire data layer with SQLite. So we had to write the SQL code once for all for both the platform, and it was really nice. And basically that's it. Here you can find some useful links that you can read if you're interested. And that's all. Thank you very much for the attention. And if you have any kind of question, you can ask me right now, or you can catch me up on Twitter or on the internet, let's say.